The angles of elevation of the top of a tower from 2 points on the ground at distances A and B meters from the base of the tower and in the same straight line with it are complementary. Prove that height of the tower is square root AB meter. Okay, fine. So the question is telling us there is an angle of elevation, there is a tower, okay, and there are two different places on the ground from which it is being observed, A and B meters. That's why we are getting, see, from 2 points on the ground. Well, let's make the tower first. So tower, we generally make a line representing a tower or a building like this, perpendicular to the surface. There will be a baseline. Let's say this is the surface of Earth on which this tower is perpendicular. Both will be 90 degrees with each other, as every construction on the ground is made perpendicular to the Earth. Let's say the top of the tower is A, bottom is B. Places on the ground from where it is being observed are, let's say this is C and this is D. But the A and B in our case are distance, not the points with respect to the question. Now join this line of sight. Line of sight means if you watch at the top of the tower from C, this will be the line of sight. Another line of sight if you will watch at the top of the tower from point D. Now, according to the question, the angle of elevation of the top of a tower from 2 points on the ground at distances A and B meters from the base in the straight line. Distance from base to point D, this can be A or B. If this is A, the second one will be B. It depends on the question. Smaller one is B meters and the larger one is A meters. Okay, well, the angles will be, this is theta and this is theta dash. Why? They both cannot be same. If they will be, it should be mentioned in the question. Otherwise, we will not consider it same. You can take theta and alpha and beta also. Okay, let's take the height of the tower as x meters. And now we will have to prove x is equal to square root of AB. Tan theta would be opposite AB, which is x, over base BC, which is, consider it equation 1. Now another triangle we have got in triangle ABD, tan. Now we got theta dash at the second angle. It would be again opposite, which is x, over base, which is DB, and DB is B meters, so this is B. This is again equation 2. We are also given that theta plus of theta dash, their sum will be 90 degree is equal to 90 minus theta dash. Then at the place of theta in equation 1, putting the value of theta in equation 1. Now, once you insert the value of theta in equation 1, you will get tan minus theta dash equals to x over A. Now, what is tan 90 minus theta? This is a formula for complementary angles. We know that tan, so this is a formula. We call it complementary angle formula in trigonometry. Cot theta, at the place of tan 90 minus theta dash, we can write cot theta dash is equal to x over A. You have cot theta dash x over A. You have tan theta dash x over B. From here, we can say x is equal to A times cot theta dash, okay? And from equation 2, if you will get the value of x, you can say x is equal to tan B times tan theta dash. If you will add them, you are not going to get A times B. If you will multiply them with left-hand side to left-hand side and the right-hand side to the right-hand side, you are going to get, this is equation 5th. Now multiplying equation 4 and 5 with LHS to LHS and RHS to RHS. So x times x on the left-hand side equal to A times cot theta dash on the right times B times tan theta dash. Now this is x square equal to A and B will be together, and this tan theta dash times cot theta dash. You know very well that cot theta dash can be written as 1 over tan theta dash will be equal to A times B, and tan theta dash times cot can be written as 1 over tan theta dash, and they cancel each other. Then you get x square is equal to A times B, right? And then x is distance of the tower AB, and when square will go to the right hand side, it will be square root A times B.